After linear regression, now let's study about polynomial regression. Now, polynomial regression is also a supervised learning algorithm which is certainly different from linear regression that we studied in the last video. Let's try and understand the details of it. Over to next. Now, as we have seen previously, in traditional previously what we used to do is we used to give a data an input to the machines, and we also used to tell them a rule, a program, and based on my rule the computer used to give me an output that is a result for the same. But in machine learning, what we do was what we do is we give both the input and the solution, and the machine learning algorithm has to predict the program. That is the rule. The machine learning gives us the rule behind it, a rule which can take me from input to the output. That is what machine learning does, and that is what I am trying to figure out with polynomial regression. In linear regression, what we used to do is we used to find a straight line that can take me from one input variable to the output variable. That is based on the study time. It can predict, it can take me to what my math code would be, and using that straight line used to predict that given a study time I can predict the math code I will get. But in case of polynomial regression, as I told you, it is a small difference from linear regression. Instead of the straight line, this time I will find the curved line. I will find a curved line that can suitably be said that based on my study time, what would be my what would be the math code, and what this time we actually learn the curved line. We can figure out the we want to figure out the curved line, and using that curved line later we will predict that if study time is given and some other variables are given, what would be the math code that I get. That is polynomial regression. Now let us try to understand polynomial regression with an example. These are the 6 elements given to me. Now I am asked to find out the total volume of all the 6 elements combined. So maybe the volume is some kind of a relation between the volume and third exponent of a side. That is, in case of cube, it is side cube. In case of cuboid, it is side to the power 3. Prism also would depend on some side base, some side exponent 3. The pyramid also some kind of side and raised to 3. Cylinder also you have pi r square h, so it is also some kind of side to the exponent 3. So you see the volume is depending on the side exponent 3, side raised to 3. that is that is the polynomial regression. So the volume, that is the very dependent variable of the polynomial regression, is actually depending upon the some kind of side to the exponent to the raised to the power of 3. That is polynomial regression. Based on what I have learned in the polynomial regression, I am now taking 4 different tests to see how well I learned. So in the first exam I say I scored 8 out of 10. In the second exam I scored 7 out of 10. In the third exam I scored 9 out of 10. And in the fourth exam I scored 6 out of 10. So I make some error. The error is, I say it has loss. That is also synonymous to error. Now in the first exam I have a loss of 2. That is I make 2 errors. In exam 2 I scored 7. So I made 3 errors. In exam 3 I scored 9 out of 10. So I made 1 error. And in exam 4 I scored 6 out of 10. I make 4 errors. Now all these errors or losses combined, mind it, combined. That is combined exam 1 plus exam 2 plus exam 3 plus exam 4. Total we call it cost. So that cost is 10 over here. The loss is individual loss. The cost is total cost. That is total cost is 10 here. Over to next slide. Previously we have already learned about cost. Now the idea what we try to achieve is to reduce the cost, that is reduce the error that I am making so that I can increase efficiency and I can increase the quality of my learning. I will do that. I will reduce the cost or reduce the error using an algorithm called gradient descent. We will study gradient descent in next videos. But for now, let's try to understand that we are trying to reduce the cost, reduce the error that we are making. Thank you. That will be all for this video on polynomial regression. Now, as always, there will be a poll on YouTube channel community. That poll will be answered within the first 7 days. You suggest me a topic for the next video. Unless you suggest a different topic, I am going to go ahead with gradient descent as the next topic. Thank you once again and have a nice day ahead.